Hey everyone. Welcome back to the channel. Today we're going to break down one of the most popular coding interview questions, the two-sum problem. We'll go step by step. First, we'll understand the problem. Then we'll go through a brute force solution. Finally, we'll optimize it using a hash map. Let's get started. Given an array of integers nums and an integer target, return the indices of the two numbers that add up to the target. You may assume that each input has exactly one solution. You can't use the same element twice. Let's take an example. Let's say nums is an array and has elements 2, 7, 11, and 15 and our target value is 9. We want to find two numbers in this array that add up to 9. Let's try some combinations. 7 plus 11 is equal to 18. Here the sum is 18, which is not equal to our target value, which is 9 in this case. Now let's check 2 plus 11, but it gives 13, which is again not our target value, which is 9. Now let's check 2 and 7 here. 2 plus 7 is equal to 9, which is our target value, so that's our answer. Now let's check the indices of 2 and 7. As you can see, the indices of 2 and 7 are 0 and 1, so the output will be 0, 1. We'll start with the brute force approach. It's not the most efficient, but it's easy to understand and a great starting point. In the brute force method, we check every possible pair of numbers in the array to see if they add up to the target. That means, for each element in the array, we go through every other element that comes after it. We add the two elements together. If their sum equals the target value, then we've found our answer. We immediately return the indices of those two elements. Let's dry run the brute force solution using a nested loop to understand how it works step by step. We are given an array, nums equals 2, 7, 11, 15, and a target value target equals 26. Our goal is to find two numbers in this array that add up to 26, and return their indices. We'll begin with the outer loop where I starts at 0. That means we're looking at nums, I equals 2. Now the inner loop begins with j equals I plus 1, so j equals 1. That's nums equals 7. We check, 2 plus 7 is equal to 9, that's not equal to 26, so we move on. Next, j becomes 2, nums j equals 11. We check, 2 plus 11 is equal to 13, still not 26. Next, j becomes 3, nums equals 15. Now, 2 plus 15 is equal to 17, again not a match. So we move back to the outer loop. Now I becomes 1, so nums I equals 7. J starts at 2, nums j equals 11. Check, 7 plus 11 is equal to 18, not our target. J equals 3, 7 plus 15 is equal to 22, still not 26. Now I equals 2, and nums, I, equals 11. J equals 3, nums j equals 15. We check, 11 plus 15 is equal to 26, that's our target. So we return the indices, 2 and 3. This dry run clearly shows how brute force compares every pair until the correct one is found. Although it works, it's not very efficient for large arrays. Let's now write the brute force code. We define a function called toSum that takes in an array of numbers, nums, and a target value we want to find a sum for. Now let's create loop code that is, for I in range len nums. This is our first loop, it runs from the first element to the last. It picks the first number in the pair. So I is the index of the first number. Then creating inner loop that is, for j in range I plus 1 len nums. Now inside that, we have our second loop. It starts from I plus 1 to make sure we don't use the same element twice and avoid duplicate pairs. This loop picks the second number in the pair. Now we will check if nums, I, plus nums, it equals target. For each pair, we add the numbers at index I and j. If the sum equals the target, then we found our answer. And we will return the indices I and j. And finally, if no pair adds up to the target, we return an empty list. But in LeetCode's version, we're told a solution is always guaranteed, so we technically won't need this line. Now after completing this whole code, let's run it. As you can see, this works. But again, it checks all combinations, so it's not efficient. That's it. This is the brute force approach, simple to understand but not very efficient. In the worst case, it checks every pair, which makes the time complexity big O of n square. Let's run it. Now let's optimize it with a hash map. This will let us solve it in one pass through the list. As we go through the array, we calculate the difference between the target and the current number using diff equals target number. This diff is the number we need to find a pair. If we've already seen diff in our map, we've found the answer. Let's solve this question. At index 0 number equals 2. We're at the first element 2. To find its pair, we calculate the difference. Diff equals 9 minus 2 is equal to 7. Is 7 already in our hash map? No, the map is still empty. So we store 2 with its index 0 and move on. At index 1 number equals 7. Next we're at 7. We calculate, diff equals 9 minus 7 is equal to 2. This time 2 is in our map, we stored it at index 0. That means we found a pair, 2 and 7, which sum up to 9. So we return their indices, 0, 1. The algorithm stops here, fast, efficient, and no repeated comparisons. Now let's code this optimized version. We will create an empty dictionary that is prev_map to store scene numbers and their indices. After that, we're looping through the nums list using enumerate. This gives us both the current index, number, the actual number at that index. So if nums equals 2, 7, 11, 15, on the first loop, I equals 0 and number equals 2. Now we calculate what number we need to complete the pair. Let's say target equals 9 and number equals 2. We do. 9 minus 2 is equal to 7, so we're looking for a 7. This diff is the missing piece to reach the target. Here comes the clever part. We check if the number we need, diff, is already in the dictionary. If it is, then we've seen the other half of the pair already. We return both indices, the one we stored earlier, prevmap, diff, and the current index I. That's our answer. For example, if diff equals 2 and prev_map equals 2 with index 0, we return 0, I. If we didn't find a match yet, we store the current number and its index in the dictionary. Why? Because maybe the number we need will come later in the list and we'll want to check back. For example, we add 2 with index 0, then later 7 with index 1, and so on. This approach has a time complexity of big O of n, so it is much better than brute force. Now let's run this code. Oh, I got an error because the last code should be inside the for loop. Let me fix it and run this code. But before this, if you like this video, please do subscribe this channel as it will motivate me to make more such videos. Just wait, I will fix it and yes, congratulations, we have successfully run this code and solved this to some problem. Comment next LeetCode problem and please do subscribe to my channel. Till then, take care, bye bye.